Okay, so in order to save some time, I'm going to give a quick video explanation so you can watch this before we meet. 7.3, we're going to talk about similar polygons. And when you're drawing a diagram of something large, like a soccer field, you don't need a large piece of paper. You can draw it on a smaller sheet and draw it to scale, which means that you're drawing the same shape, but just in a smaller size. And we say that those two figures are similar in shape. They have the same proportions and the same angles. The lengths are not equal. The lengths are in proportion. So what that means is if we were to draw two figures, polygons like this one, PQRST and VWXYZ, then the angles that are corresponding are congruent. In other words, P is congruent to V, T is congruent to Z, all the way around. But the side lengths are not congruent. They are in proportion. In other words, their lengths have the same ratio. So like PQ, which is this one, is 20 over VW, which is 32. That's going to be a ratio of 20 to 32. Every single other side will have the exact same ratio. So like PT and VZ, those would have the same ratio. They might not be the same numbers, but they would have the same ratio. Okay, so the properties of similarity are some of the same properties of equality and congruence. For example, similarity is reflexive, symmetric, and transitive. If two polygons are similar, then the ratio of the lengths of two corresponding sides is called the scale factor of the similarity. So in this polygon, since PQ over VW is 20 over 32, then the scale factor of pentagon PQRS2 to the second pentagon is going to be PQ over VW, which is 20 over 32, or 5/8. So the next example, one way we can label when we're going from one polygon to the other so that we don't mix up the lettering is we call one of them A and the other A prime. That way you know exactly which angle you're referring to. A and A prime, B and B prime, C and C prime, etc. So for the quadrilateral ABCD being similar, and that's what this little cedilla is right here, it means similar to quadrilateral A prime, B prime, C prime, D prime, then we're going to find the scale factor. So to find the scale factor, we find two that have their numbers already written in, which is this one and this one. DC over D prime C prime is 2/3, 20 over 30. And then find the values of X, Y, and Z. Well, once we now know the scale factor, then we can find the other things. So for example, AB is going to be proportional to A prime B prime. So that means X over 21 is the same scale factor as DC over D prime C prime. So X over 21 would be 2 over 3. And then when you multiply it out, you get X equal 14. Same thing for the Y. We're going to pick these two sides, and we would have 8 over Y equals 20 over 30. Solve for that. And then with the other, for Z, it's 10 over Z equals 20 over 30. And solve for that, or 2 over 3. To find the perimeters, once we have found all the sides, then ABCD has a perimeter 52. And then the other one, A prime, D prime, C prime, D prime has a perimeter of 78. And the ratio of the perimeters, 52 over 78, is 2/3, which is the same as the scale factor. So whenever you compare the ratio of the perimeters with the scale factor of the similarity, then you'll discover that they are the same. Okay, let's see. So let's go on here to the classroom exercises. Do these to the best of your ability, and we'll go over the ones that you're not sure about. Go ahead and fill these in on the bit paper sheet itself, and you can find that link up here at the top. I'll also paste it into, let's see, I will send it to you in email so you'll know, but I think you already have it. Come into this bit paper, fill this out before we meet, and then do the written exercises 1 through 23. Don't worry about these right here, but the next section will be 7.4, and I'll have a separate video for that one. Thank you so much. Have a great day.